Hello, today we're going to go over Honors Chemistry Chapter 2, which is about measurements. Section 2.2 discusses the units of measurement, and this table lists the SI, which stands for International System, base units. These are the units we use to measure the mass, length, time, temperature, amount, current, and luminosity. So for mass, we measure in kilograms. For length, we measure in meters. Time is in seconds. Temperature is in Kelvin, and moles is used for the amount of a substance. Unit prefixes come before the symbol, and they are used to modify the unit's magnitude. So in the next slide, we're going to see these are the prefixes that we use in chemistry to modify how big or small a unit is. Our example that we're going to use is the meter. So if for a meter, you guys know a meter is about 3 feet long. If we're measuring something really big, like the distance between your house and the school, then we would use kilometers or maybe megameters, but that's a very big number. And then very, very far away, we would use gigameters. So what do these prefixes tell us? When you add the prefix giga, for example, in front of meters, you're meaning 1 billion, which is 10 to the 9th power of those units. So 1 gigameter means 1 billion meters. When we add the prefix mega in front with the capital M, that means 10 to the 6th power, which is a million. So 1 megameter is 1 million meters. Kilo means 1,000. And so if you have 1 kilometer, you have 1,000 meters. Okay, down here we have the smaller units. So if we're measuring something that's smaller than a meter, smaller than 3 feet, then we might use a decimeter, which is 1/10 of a meter. So if you take that meter stick and divide it into 10 equal parts, you would get 1 decimeter. Another way of rewording that is 10 decimeters are equal to 1 meter. And using this avoids the fraction of 1/10. For centimeters, centi, like a century, means 100, but a centimeter is 100th, or 10 to the negative 2. So 1 over 10 squared, which is 1 over 100, is the meaning of centi. So there are 100 centimeters, which are small, in 1 meter. Milli means 1,000th, so 1,000th of a meter is a millimeter. In other words, 1,000 millimeters make up 1 meter stick. Micro is a millionth, so there are a million. This is supposed to be the Greek symbol mu, mu. Let's change that to symbols. Insert character. We want to make it a mu, which looks like that. There it is. Greek mu. Okay, so micro is this Greek letter mu, and that means that you have a million micrometers in 1 meter. Let's fix this as well. There we go. For nano, nano means a billionth, so there are a billion nanometers in 1 meter. And pico means a trillionth. There are 1 trillion picometers in 1 meter. There's even smaller units that we use when we're talking about atoms, which and protons and neutrons. That would be a femto, an atto. You guys can look those up on your own. So what we're going to be doing is converting from one unit to another in this section. And this is so that we can use these down the road when we're talking about moles and grams and atoms. And what we call this method of converting from one unit to another is dimensional analysis, which is just a fancy way of saying canceling units. A conversion factor is a fraction where the units on top are what we're trying to find and the units on the bottom are what we are given. Here's our example. So if I were to tell you you have 35 inches of, let's say, string, and I want to know how many feet is that. It's the same length of string whether you measure it in feet or inches. So how do we convert from one to the other? We need to know the relationship between inches and feet. So we know that there are 12 inches in 1 foot. These two things are equal in their length. 12 inches equals the same length as 1 foot. So when I write it as a fraction like this, I'm really putting the same amount over itself, which if you have any number over itself, that's just 1. So this doesn't change the size of your string. This just changes what units the string is being measured in. So we're going to write 35 inches, and I always put it over 1 just to remind us that this is on top and it's going to be multiplied by the top numbers, and the 1 on the bottom is going to be multiplied by the bottom numbers. So I'm going to write 35. This is my given number. These are my given units of inches. So I put inches next to the number, the units, and the number together. And I'm going to multiply it by a fraction. So I always set up my problems in this way, and you'll see that in a second. Next, how do I know from my equality here which one goes on the bottom and which goes on the top? That's why it's important to write your units. Whatever you're given in the beginning, those units go on the bottom of your conversion factor. And the one that you're looking for, that goes on the top of your conversion factor. And then you can see it's 35 times 1 divided by 1 times 12, which is just 35 divided by 12, and that's 2.9 feet. The inches and the inches cancel. So anything you have on the top of the fraction and the bottom that's the same will cancel out, and we're left with feet. And then we want to think, does our answer make sense? Well, 3 feet is 36 inches. So if we have 35 inches, that's almost 3 feet. And so our answer of 2.9 definitely makes sense. Okay, here are some other problems just to practice our conversions between units. So we are going to write down how many seconds are in the month of September. September has 31 days. Okay, so I'm going to put 1 month, MO for month, over 1 is where I'm starting. Okay, and we could put the month of September specifically, but I'm just going to put 1 month, times, here's my conversion factor, that's an X, times conversion factor, 1 month, specifically the month of September, has 31 days. Okay, I'm just going to put D for days. Okay, so now months have canceled out, and we are at days. So 1 day, to get closer to seconds, I'm going to change that to hours. There are 24 hours in 1 day. Okay, and how do I get closer between hours and seconds? 1 hour is 60 minutes. Minutes is 1 hour. Okay, and last but not least, 1 minute is 60 seconds. So we are going to use our calculator, and we are going to do 1 times 3 times 24 times 60 times 60, and we get a very large number, and there's only ones on the bottom, so we're dividing by 1, which doesn't change our answer. So it is going to be a big number that I'm going to have to write down here at the bottom. 259 1,200 seconds. Okay, example 2, an average American eats 0.58 pounds of sugar a month. How many pounds of sugar per year is that? So we're going to write our given number, this is our number, with the units of pounds, and it's a month, in other words, per month, and per means it's on the bottom of a fraction. So let me show you what that looks like. We have 0.58 pounds, LBS, per 1 month. Okay, and what it wants is pounds per year. So I'm just going to change this bottom unit down here. I'm going to leave the pounds up top, and I just want to get rid of the months. So in my conversion factor, I'm going to put months on top because that's the one I want to cancel out. So if I put months on top, then these will cancel. And what I want is year. So I'm going to put year on the bottom. How many months are in 1 year? That's an easy answer. 12 months, 1 year. Okay, months have canceled out, and now I can look at the units that I have left. I have pounds per year after those months canceled out. So I'm going to do 0.58 times 12, and I get 6.96, so almost 7 pounds of sugar per year. That's a big bag of sugar. 6.96 pounds per year. Okay. Here's some more examples for us to try. We're going to start by always writing the given number, so 5.4, and the units, kilograms, over 1, times some conversion factor. Okay, now what goes on the bottom? The units that we're given. They gave us 5.4, that's our given number, and they gave us kilograms, that's our given units. So kilograms are going to go on the bottom down here, and what we want, which is grams, they're asking us how many grams that is, that goes on the top. Okay, now if you don't remember, we can go back up to our chart and we can find kilo, and we know that there's 1,000 smaller units in 1 kilo unit. So this was kilometers, but now we're talking about kilograms. So there are 1,000 grams in 1 kilogram. Just replace the M where we had meter with G for grams. So kilogram, there's 1,000 grams. Going back to our problem, that means I have 1,000 on top. There's 1,000 grams. In 1 kilogram, and if you multiply a number, kilograms cancel, by 1,000, you're moving the decimal as many places as there are zeros to the right. So there's 3 zeros, so I'm going to move the decimal 1, 2, 3 places, and I will get 5,400. And you can do that on your calculator as well if you don't want to just move the decimal around. There's that many grams. Okay, here's another tricky way to do this problem. You have 5.4 kilograms, and if you remember that kilo literally means 1,000, that means you have 5.4 thousand grams, or 5,400 grams. Okay, down here, I know these are not exactly how gigabytes work, but there's not a lot of giga things out there, so we're going to pretend that this applies. So we have 2.5 is our given number, capital G for gigabytes. Okay, over 1. We always start with our given number and our given units over 1, and then times a conversion factor where gigabytes goes on the bottom because this is what we're starting with. So 1 gigabyte, I'm going to put just B for byte. Okay, so 1 gigabyte, and this is a very ugly G. Let's fix this G. Okay, that's a little better. Remember the prefix giga meant a billion. And I'm actually going to leave it in scientific notation. This is kind of tricky also, and we're going to go over scientific notation specifically, but it is 10 to the 9th power. That means 1 with 9 zeros. And if I do that, I can do something sneaky over here. I can put 2.5 as my answer. 2.5 gigabytes cancel on top and on bottom. They're the same, so they cancel out. And I should have written bytes right here. So I have 2.5 times 10 to the 9th power. That's how many bytes I have. 2.5 billion bytes is my final answer. Okay, for the next problem, here's our given 0.46 milliseconds. So 0.46 milliseconds over 1. And I want milliseconds to go away, so I'm going to put them down here. And we're trying to change it to seconds. It says, what is this in seconds? So I'm going to put seconds on top. Okay, and if you guys remember from the chart up here, 1 second has 1,000 milliseconds. Milli means 1,000th, so there are 1,000 of those smaller units in one bigger unit. Okay, and since I'm dividing by 1,000, this time the decimal is going to move to the left as many places as I have zeros. So I have 3 zeros, so it's going to move 1, 2, 3 places to the left, and I will get 0.00046 seconds. Okay, as my final answer. All right, last but not least, how many micrometers are in a millimeter? I have 1 millimeter over 1 as my given. I want milli on the bottom, so I'm going to put millimeters down here. Lowercase m, and I don't know how many micrometers are in a millimeter. But I do know that there are 10 to the 3rd, or 1,000, in other words, millimeters in 1 meter. So millimeters can cancel out, and now I know how many meters I have. And I can do another step right here where I'm getting rid of the meters. 1 meter is how many micrometers? Micro meant a millionth, so that means 10 to the 6th power, or a million. Micro, remember it's this Greek symbol mu. Micrometers, there's a million micrometers in 1 meter. Meters have canceled, and now I've changed it from millimeters to micrometers. And just like I did something tricky up here, 10 to the 6th over 10 to the 3rd, when you have an exponent on top and an exponent on the bottom, you subtract the bottom from the top. So it would be 6 minus 3, which is 10. We have this 1 over here. 1 times 10 to the 3rd power micrometers. And that is my final answer. Okay, that is how we convert from one unit to another using dimensional analysis and conversion factors. And we will go over metric slide next time. Have a great day.